Hello,
Hello, good morning. Good
good
morning, Wageesh.
morning. Good morning. So, yeah, hope I am audible.
Yes, you are audible, sir. So let us
Okay,
start.
thank you so much.
Okay, let's. So good morning and warm welcome to one and all to this special invited guest lecture on India's vision and achievements in space exploration, organized by Department of Physics, Patna Science College, Patna, in association with IQAC Patna Science College. A warm welcome to Dr. Wageesh Mishra, resource person for this event. Uh, Resource person for the event. Welcome to our principal, Professor Dr. D. N. Thakur in absentia. Welcome to our HOD, sir, Professor Shankar Kumar. Welcome to the teachers of Department of Physics and other departments, Patna Science College, and welcome all the student participants to the college. Uh, Now, as you all know, India is celebrating its first National Space Day on August 23 today with the theme Touching Lives While Touching the Moon, India's Space Saga. It was on this day last year that the Chandrayaan 3 mission successfully accomplished the soft landing of Vikram lander on the lunar surface. This day marks India's historic achievements as it was the day when the country became only the fourth in the world to land a rover on the moon and the first to land near the southern polar region. Having achieved a huge success in the moon mission, the Indian government officially declared August 23 as the National Space Day, commemorating India's growing progress in space exploration. So now, without wasting much time, let me have the privilege to invite Dr. Sanjay Kumar, Department of Physics, Patna University, to introduce our resource person.
Good morning, all of you. First of all, I would like to welcome Dr. Wageesh Mishra. Dr. Wageesh Mishra is an assistant professor at Indian Institute of Astrophysics, Bangalore, and an eminent scientist in space research. He completed his PhD in the area of solar and heliospheric physics from the Premium Research Institute Physical Research Laboratory, Udaipur Solar Observatory. Before joining the regular position at IIA Bangalore, Dr. Mishra was a postdoctoral fellow at Max Planck Institute for Solar System Research, Germany. He also worked as a postdoctoral fellow at University of Science and Technology of China and held a visiting research position at George Mason University, Virginia, USA. Dr. Mishra is a leading science team member for the Visual Mission Line Coronagraph payload on board Aditya L1 space mission launched in September 2023 by ISRO. He has received several recognitions and awards in India as well as abroad. A few of them are Associate of Indian Academy of Sciences, NASI Platinum Jubilee Young Scientist Award from the National Academy of Sciences, India, and President's International Fellowship Initiative from the Chinese Academy of Sciences. He has published more than 60 research papers in reputed national and international journals. I am very thankful to Dr. Mishra for agreeing to give this online special lecture at Patna Science College on the occasion of Space Science Day. I would also like to mention that at present Dr. Mishra is a resource person in post-war capacity building workshop at Samarkand State University, Uzbekistan. So once again, I would like to thank Dr. Mishra for finding time from his very busy schedule for this special lecture. Thank you.
So, so now I request sir to take over the session and enlighten us with his deep knowledge on the subject. Over to Dr. Wageesh Mishra, sir, and the stage is all yours, sir.
Yeah, so hello. So, am I audible?
Yes, you are audible, sir.
Okay, thank you so much. And first of all, I apologize for being late. Actually, the country I am in 13 minutes behind, so I just missed the time. So India is 30 minutes ahead. So sorry for being late. And if my internet connection gets unstable, please let me know in between so that I can try to stop the video for a better connectivity. And I thank Sanjay Kumar for inviting me for this lecture and introducing me. And also I thank Rohit for conducting the session and moderating. So I can share my slide. So if it is visible, let me know so that I can start. Yes. So is the slide visible?
Yes, yes, sir. Slide visual.
Okay, good. So is it in the full screen mode?
Yeah, it is in
Okay.
full screen mode. Yes.
Okay. So can you please once confirm again if the slide is visible?
Yeah, yes, sir. Slide is visible
Okay.
in full screen.
Okay.
Yeah.
Okay, thank you so much. So today I will be speaking on India's vision and achievement in space exploration. I am here to speak on this important day, 3rd August, which is being celebrated as National Space Day in our country, India. The theme of this National Space Day is touching lives while touching the moon, India's space age. We all know that this day is being celebrated to celebrate the India Chandrayaan 3 lander, means mission landing on the moon, South Pole. So as I will proceed with the talk, the outline of my talk is I will start with brief introduction how the space research in India started. And then slowly as I progress through the talk, I will put on like bring in the history of some formative years of ISRO, how it conducted the experiments, what were the major missions launched by the ISRO, and then slowly the present last decade revolutionary mission by our space agency ISRO. And I'm very happy to be in this giving this talk at Patna Science College. In fact, I remember 2 years before being in Patna Science College and giving the another talk on the National Science Day. So we all know that big research, especially something like space research, which is beyond our Earth, is not very in one day. It doesn't happen in one day. So if we go into the history, we will see that the first space research in modern era was started by S.K. Mitra, who in fact was a ionospheric physicist and who started looking at the ionosphere with the different techniques who was actually the main person behind the Indian nuclear program. And friendship, we can say, the space and nuclear policy of the India in the beginning in 1950s and 60s. These two visionary scientists actually led to several institutes, building up several institutes. So as I will proceed, I will try to highlight the Vikram Sarabhai. To give a brief introduction for the students, Vikram Sarabhai was born to an industrialist family in Gujarat. He was very passionate for studying physics, and for that, although he studied his initial education in Gujarat itself, but for higher education, and in Cambridge he completed his degree, undergraduate degree tripos, that time it was called, and then during that time actually Second World War started and he returned to India. He continued his research work under the guidance of C.V. Raman, the one of the visionary scientists proposed Raman scattering. He also got the Nobel Prize. C.V. Raman got the Nobel Prize. He was the physician, in fact, who got the Nobel. So we can see how C.V. Raman put the India on the world map. So Vikram Sarabhai returned to India from Cambridge and wanted to carry on his research on the cosmic rays. And then he contacted C.V. Raman. He was that time director of the Indian Institute of Science. He did lot of studies on cosmic rays. Mainly he collected the data in the Kashmir Valley, Gulmarg region. And then as the Second World War actually ended, he again went to Cambridge and submitted his PhD thesis there. Sarabhai actually, after submitting his PhD thesis to Cambridge, he returned to India and he wanted to start a space program in India. And for the first institute, you can see that he actually founded this institute. Just I want to bring the context. Institute was not very easy. Institute was not very easy. It can solve the world map. That how important is to have funding or the support from the government. And in fact, the successive government, as we will proceed through the talk, we will see that successive government been space program of the India. In fact, PRL was there in Ahmedabad for 10 years after foundation, and then the Vikram Sarabhai wanted to expand the PRL infrastructure and he wanted to expand the research into different areas. And that time, PRL was since autonomous institute, and there was no space commission at that time. So Vikram Sarabhai approached. To expand PRL research. I actually formed a committee. To expand PRL research, I actually formed a committee. The usual procedure, and by the committee of the news at that time, we can see when this collaboration and PRL came, it became a big news. And this led to, in 1962, Department of Atomic Energy formed a national committee. And the mandate of the INCOSPAR was the launch United States and Soviet Union were one after another in the space research. But Vikram Sarabhai was very visionary. He made clear that India would carry on the research only for the benefit of the society in the beginning. And that was how the Indian space program was built, the basic foundation of the space program. So we can see that PRL contribution was the formation of INCOSPAR, Indian, and in fact, Dr. Sarabhai was made president of INCOSPAR. Most of them were from PRL. So, in fact, India started its space program after, we can say, Americans. We can see the timeline. 1962 is just very close to the first satellite sent by US in 1958, Explorer 1. And then in 1957, before the US, Soviet Union has sent its one satellite Sputnik. We can say that in the beginning also, we were not very far from the space program. The INCOSPAR activity, in this talk telling a story, and at the ISRO. So Dr. Sarabhai actually established the Oriel rocket launching and TER for launching rockets, and from this location only, sounding rocket was launched from US made. We can see in this picture, this rocket is actually, we were already in a position to launch indigenous rockets and satellites. In fact, Indian government assigned all the administrative roles of space activity to PRL actually. And so we can see the whole INCOSPAR. We will see that this INCOSPAR was later named as ISRO. So this visionary scientist, Dr. Vikram Sarabhai, in fact, developed in India. Importance of CV to conduct and expand. We all know that very supportive of space program should deal with larger section of the society and students. They know that how difficult it is to train the next generation of the researchers. And these two strong pillars, why we celebrate them, Sarabhai and Bhabha, because they are the founder of this program and the nuclear program into India. We can see that soon after the Sarabhai passed away, Satish Dhawan took the leadership of the space commission, and then again we can see the space program continued, and we had several satellites launched after Aryabhat, Bhaskara, and others, Rohini satellite. Then, as I told that we up to 1970, India could develop the satellite, indigenous satellite, but we were unable to launch. So the next 10 years of the program, ISRO made the one who like if we have worked with ISRO, we know that ISRO works as a mission in a mission mode. It means ISRO decides that in the next 10 years we need to develop this thing. Actually, we all should be proud of the ISRO achievement. If you know ISRO engineers and scientists, you will know that at one time they work with a mission. Even this legacy and this background and this tendency is developed over years and years by Vikram Sarabhai and Bhabha. So, so in 1980, actually, the whole ISRO program was dedicated to develop launch vehicle, satellite launch vehicle (SLV), so that India could launch its own satellite. Because this is the first step to go into space, either for research, either for any communication or navigation satellite, right? So in 1980s, India developed the first launch vehicle called SLV, and with this SLV, Rohini satellite was launched in 1980s. So we can see that India became almost the seventh country in 1980s actually. After Soviet Union, USA, France, Japan, China, and UK, India was the seventh country to have the rocket launching capability. And this is a great thing. We can see that up to 1980s, only 7 countries in the world could launch their own satellite. Even today, we know means there are several countries which don't have launch vehicle facilities. Their satellites either is built by different country, and if somehow they build, it is launched by different country. It is the dependence on the other country. And Vikram Sarabhai was very visionary that India should not depend. We should collaborate. We should work with the foreign means another space agency, but we should not depend on them. And as a result of that, after almost 9 years of Vikram Sarabhai passed away, India had the capability to launch its own satellite, made its own satellite, and that was the Rohini satellite. We can see that again the space program continued for 10 years, developing the modern version of satellite launch vehicle. Initially, we had SLV-3, then we developed launch vehicle, augmented satellite launch vehicle. When I say we developed the launch vehicle for the 10 years, it means our launch vehicle were made in such a way that it can lift the heavy satellites. Basically, in the beginning, our launch vehicles were small. It could not take heavy weight. It was limited to few tens of kilogram. But then the idea was to develop stronger and stronger launch vehicle. Out of that, we developed the PSLV. We all know that PSLV, Polar Satellite Launch Vehicle, is one of the strong launch vehicle with the ISRO. And no doubt for the next 10 years, this launch vehicle is working. In fact, most of the launch today, be it Mars mission or Chandrayaan or Aditya L1 mission, as I will show, these all were done by PSLV. And we can see up to 1980s and 90s, India developed, means the ISRO developed several space center all over the world. The idea was to develop and build the wings, which is not only for the science, but also for doing. Yeah, there is some noise. Hello. Yeah, should I continue? Hello. So Sanjay, am I audible?
Yes, sir. Yes, sir. Continue. Yes, yes, sir.
So
You are audible, sir.
should I
Okay.
continue?
Yes.
Okay, okay. I think I am exceeding the time. I will try to summarize. I took a long time in the history probably. Sorry for that. I actually Yeah, I was very passionate to tell the story, but I will try to jump to the current developments. Yeah, so we can see that several centers of ISRO is developed. In fact, the Space Saga mission formulates the policy, and most of the ISRO center mandate is to work towards them. And we can see all over the country the centers are there. We also remember that India means if you remember the Kargil war and the news at that time, the we were denied GPS services, right? United States refused to help India with GPS services. And at that time, around 2000s, it was felt that India should develop its own navigation, means own positioning system. In fact, for the next 10 years, India started launching series of satellites called Arya and Axis, which is India with global positioning system. And this is named as Navik constellation. And now it works. Actually, ISRO is working further to expand this system so that we can have our own GPS system. Currently, there are few GPS system into the world. Means one is led by US called GPS. We all are familiar when we think for positioning system, knowing the position, we first think GPS. But this is named for the company, means the constellation of satellite of US. And then we have a GLONASS, it is by Russia. And then we have BDAO by China. And then we have a Galileo by Europe. India is actually joining this frontier and developing its own positioning system so that we don't need to depend on them. Till now, the satellites which are launched are only giving the position of the Indian region and extending to some ocean region of the India, around the ocean, to some miles into the ocean. But India need to develop a more accurate precision system, and work is being done in this direction. And just to highlight, in 1980s and 90s, most of the ISRO program which was started is called INSAT, Indian National Satellite Program, and GSAT. This whole program, even today, the series of these satellites are being launched once and then. These satellites provide TV broadcasting, meteorology developmental, education, remote sensing. So these are the very powerful satellites. And without that, actually, we cannot think for telecommunication in our country. So this program, Department of Space actually set up this program, and the mandate was to continue with this program so that if one satellite gets dysfunctional, which serves inside program, we launch and replace it by another satellite. So even today this works. So this Indian National Satellite System, INSAT and GSAT, you might have heard geosynchronous satellite system. These are two satellite systems in India that provide telecommunication services for the subcontinent actually. We provide services to many other countries as well. What services we get? We get TV broadcasting, the internet we use, the weather forecasting, meteorology, satellite news gathering, societal application, disaster warning, and several rescue operations. Actually, these satellites image from the top different areas of the country. If in some area flood is coming, we already have pre-warning for the same. So it means this INSAT and GSAT are very powerful for disaster management. They have very good accuracy. So both INSAT and GSAT satellites are placed in geosynchronous orbit. So you can know the geosynchronous orbit. You can read about this. And INSAT satellites are multi-purpose in fact. Some of the satellites in this series are also used for military purpose, but that services are not available to common person. So the INSAT and GSAT fleet has enabled DTH payers to serve the Indian market with an active subscriber base over almost 70 million. So we can see this ISRO bigger program called INSAT and GSAT is for the common people. And that's how ISRO contributes. If we see the vision of Vikram Sarabhai, he started that India should not fight the space race. We should develop the infrastructure to serve the common people. Because at that time, developing the infrastructure when the country was in lot of problem, poor, hunger, and other things, poverty, it was a big thing to get the fund to develop a space program. Then we can see in the 21st century, the very strong launch vehicle called GSLV was launched. And this capability actually, the whole world was surprised that developing the geostationary satellite launch vehicle, which can lift several hundred kg of the satellite mass into put into the space. In fact, the India Chandrayaan 1 in 2008 led to several discovery, and that again put India in the top 10 of the world. So ISRO has developed, but I will try to to brief you of the some important missions. So let us go Chandrayaan. We all know that this Chandrayaan 1, again, I will be like emphasizing, I am of the view that most of the scientists or even the academicians are critical of the government influence to the different research institution or the space program. But especially for space and defense, even for the strategic purpose, for the geopolitical purpose, the government should own the bad or good. If tomorrow space program does some harm to some country, the government is responsible. If it does good, the government, the political leadership should take the credit and own even if there is some loss. So we all know that Chandrayaan 1 was actually, this was the mission approved by Atal Bihari Vajpayee government. Of course, he did not continue, but then it was launched. In fact, this mission was first announced by Vajpayee, and there was a meeting in the Indian Academy of Science in Bengaluru when the Astronomical Society of India (ASI) and Indian Academy of Science, several members and fellow gathered and given inputs that India should go to the Chandrayaan 1. There was a national level committee made from different people from different expertise, geologists, astrophysicists, space scientists. So they all given their input what should be the instrument on the Chandrayaan 1. And then Chandrayaan 1 was launched in 2008. We all know that it discovered the water. We can see here the how this mission was sent. In fact, again the India became fourth or fifth country into the world who sent their any probe on the moon. If you see the science from Chandrayaan 1, actually the direct evidence of water was actually came from one of the instrument made by India. We all know that on Chandrayaan 1 there was an instrument which was made by US actually, moon mineral mapping. That also discovered the water, but before that Indian instrument had already enough research data to collect, scientists had analyzed, and in fact in the beginning there was a discussion whether the discovery of water on the moon, direct evidence, should be given to the instrument which is developed by US or the Indian. Later, even both space agency discussed and given the credit that Indian instrument called Chase, which was the moon impact probe. So we know that Chandrayaan did not land on the moon, but it had a probe which actually put down from Chandrayaan 1, which hit the moon south pole, and then lot of data were collected. In fact, our instruments provided the evidence of volcanic vents, lava ponds, and several other things. The research was done to understand the potential habitability of the human on the moon, and several research were done in this direction. And the revolutionary mission, going to the moon was still a little easier, but going to the Mars, it is like an interplanetary journey. And again, we can see that Mars Orbiter Mission MOM, popularly known as MOM, was launched in 2013, and it is mission actually worked for almost 7-8 years, and it had provided India the first nation in the world which in the first attempt reached to the Mars orbit. This was a great milestone achieved by the ISRO. Today, in the other space agency also take ISRO very seriously because the engineers and the scientists are so fine with the and the technocrats are so smart that they develop the mission which can even succeed in the first time, which no other country have done in their first attempt. Result from the MOM, I am not going to into detail, but it actually have mapped the whole Mars surface, calculated the albedo, the reflectivity of the surface, several gases, clouds, several things on the Mars has been discovered. Coming to this direction, till now we were sending missions which were primarily technological mission. Technological missions means ISRO need to demonstrate the capability to reach to the places where most of the space agency has reached. But then there was a need to make a fine instrument which is well calibrated to take scientific measurements not only of the space and near Earth bodies, but the galaxies which are billions and millions light year ahead and like distant from us, from the Earth. In this series, ISRO launched the first satellite called AstroSat in 2015. It is still working, providing a lot of data. We can see that ISRO works with collaborating with several academic institutes in the country. Again, we can see here are the participating institutes which actually contributed to AstroSat satellite. It is a multi like wavelength satellite. We can see here again the physical research laboratory is involved, which is again, which was actually I described the Homi Bhabha, like the sorry Vikram Sarabhai founded that. So we can see that the legacy of the PRL is continued. It is participating in several even science mission called AstroSat. The mission is still working, and we can see that AstroSat has provided the data for several galaxies which are millions light year away from us. In fact, the data from AstroSat has discovered several like main sequence stars in different galaxies near Aegean and other things. In fact, the observation of one black hole in a binary rotating system was also developed by means discovered by AstroSat data. The point I am making that developing a scientific instrument is a great thing because you need the precision. The instrument should be of precision so that you make an interpretation of data, and that is not an easy task, right? So science results from AstroSat has again surprised means the other space agency because this was one of the first multi-wavelength observatories sent into space. In this series, we all know that Chandrayaan 2 was launched in 2019 and it had some problem. Vikram lander could not softly land on the like moon. In the last minute, there was some problem. Vikram lander lost contact and soft landing could not happen. Following that, actually, if you remember this photograph when we can see our Prime Minister Modi ji actually trying to console at that time chairman of ISRO. In fact, he supported for the next follow-up mission called Chandrayaan 3. And we can see that Chandrayaan 3, we all remember that it was launched in July 2023 and reached, means finally the lander actually touched the surface on 23rd August, the day for which we celebrate National Space Day. This was a great thing because to land softly on the moon, if the orbit is complex, the gravity is very less, so soft landing on the moon is a very tricky thing. And this was achieved by India. It is the fourth country actually to touch the surface of the moon. In fact, to touch the South Pole, India is the first country. So you can see this animation in to save the time. I will not go into this, but again another instrument called Aditya L1. I am a solar physicist. I work solar, and this mission is dedicated to study the sun. There are several instruments on this. Actually, if you see, again the orbit of the L1 is very complex because L1 is almost 15 lakh kilometer away from Earth, while the moon is only almost 4.5 something, 4 to 5 lakh kilometers. So it is 4 times away from the moon distance from the sun. So this is again a much complicated mission, and sending an instrument, launching into a like keeping the instrument at a point where the gravitational stability is there, like first Lagrangian point. Again, we can see that Aditya L1 had several instruments. One primary instrument was visible emission line chronograph VELC, which was again made by the IIA Indian Institute of Astrophysics, where I am working. I am also a part of this team. And we can see the other instruments called SHOOT, and there are different participating institutes, IUCA and PRL. So PRL has one dedicated instrument on this Aditya L1 aspects. So we can see that the most recent launch mission of the ISRO Aditya L1 also have instruments from the PRL. It means the legacy of instrumentation in PRL is carried forward by the following scientists and members. I will not go into the science objective of the Aditya L1. Most recently, in this year, we launched another satellite called X-ray polarimeter satellite. Why I want to highlight? Because these missions, these scientific mission is aiming to take actually human into the space. But for that, this mission will go into several stages. In first few steps, my understanding is that they will carry a robot like human called Vyom Mitra and try to understand the gravity and the space radiation dosage and several other experiments this robot will like conduct. Depending on the input and the further understanding, actually the plan is to send human and four astronauts are actually being trained for this. So in this four, you can figure, you can see they all are basically Air Force pilot, if I understand, yes. And two of them have got some training from the NASA and others are getting into India. We also know that India has a very strong again mission called Venus orbiter mission called Supriyan, and it will be sometimes launched after 4 years, 2028. The idea is to understand the Venus surface temperature and atmospheric composition, how the lack of light is there on the Venus, because the idea is to understand different planets. If we don't understand our solar system, there are discoveries of exoplanets, planets around different stars. So once we understand our sun and the planet of our solar system into great detail, the idea is we can understand other stars and other planets orbiting around other stars. This is how the knowledge gained by studying the sun or solar system object is actually can be extrapolated to understand other bodies, celestial bodies. So I can stop here. I thank you so much for your attention, and sorry for if I exceed the time, as probably the lunch time is coming. So thank you so much for giving me this opportunity. If there are any questions, I would be happy to take them.
So thank you so much, sir, for your wonderful lecture on the topic India's vision and achievements in space science. We have learned a lot from this wonderful lecture. Now, before we end the session, I invite Dr. Shankar Kumar, sir, HOD, Department of Physics, Patna Science College, to present formal vote of thanks. Over to you, sir.
धन्यवाद वागेश सर, आपने हमारे बच्चों को हम इस समूह को इस प्रथम राष्ट्रीय पर हमारे अंतरिक्ष और इन उपलब्धियों में भारतीय जो अपना इंडिजिनस साइंस, स्पेस साइंस में रिसर्च है, उसके पीछे का साइंस है, उसमें बृहत रूप से 1940 के दौर से लेके आज तक के दौर में हमने क्या क्या अचीव किया, कैसे लॉन्च व्हीकल एसएलवी से एएसएलवी वैरायटी के लाइट्स में उनकी उपयोगिता, भारतीय तकनीक के बारे में उनको भी बहुत बहुत धन्यवाद।